So, hello everyone. I'd like to welcome everybody coming to my podcast today. Temporarily, I've actually named my podcast Kai Podcast. All right, so welcome. Let's start about today's podcast. Today, we're actually going to explore an interesting and actually global, well-known, phenomenal education way, which is actually attracting a global attention. And it's actually called a phenomenal-based learning, and it's actually started by Finland. Is it really better than traditional education? So today we're going to dive in and we're actually going to uncover the mystery of it. So I've actually collected five questions that has been really well known on the internet by the viewers and by educators. These questions has been seriously discussed and debated. So today let's talk about it for a little bit. So before we dive deeper, let's start with our first basic question. So what is the definition of PHBL, which is phenomenal based learning, and what makes it different from a traditional teaching? So by starting it, I'm going to explain phenomenal-based learning just like its name. It started with a phenomenal case that existed in our real world. By that, students are actually examining a phenomenon that happens in our life. For example, the recently climate change, our environmental crisis, global warming. Students are going to examine these projects by collaborating with others using major and multi knowledge from different subjects, for example, chemistry, geology, and of course, linguistic English. So that's why they can pull off a project together. And what makes it different from a traditional teaching? In traditional ways of teaching, we started to learn subjects one by one individually, right? We started to learn English, we started to learn chemistry, math by itself. But in this way, students are actually learning multi-subjects together. They were using mathematics to solve the data analysis. They will actually use geology knowledge to map out the city landform, and then they will actually use linguistic knowledge to convey a survey to viewers, to people, and then they will pull up the subjects together in order to collaborate them into a workable solution for the phenomenal problem. And from that, they will actually start to reach out to local community and even to authorities to provide solution towards these organizations. So we're actually examining students from their academic learnings, but also we're actually examining students as a civic citizens obligations. So they're serving their city and they're serving the place that they love. All right, so let's talk about the second questions. Now what does the PHBL lesson actually look like? And how is it different from a traditional way of teaching? In the PHBL lesson, students won't really need to, sit by their own using books. There's actually not materials limitations. Students will be sitting into groups. Teacher will be sending out projects. There are different proposals that might be interested. Once they've drafted a proposal within team members, they have to divide it into conquer. Some will be gathering data from internet. Some will be doing surveys, and some of them will be drafting notes for others. So students are actually collaborating with one another in this way. But in traditional classroom setting, student will be sitting individually, only only with a textbook, with a pen, writing what the teacher is teaching. So instead of this traditional, or we can say maybe a bit tedious way of teaching, students are innovating, students are inventing, teachers are shifting from a traditional educator character into a person who is trying to lead them to their curiosity and to the right pathway. All right, so let's start with the third question. PHBL is gaining global attention, but what makes it so special? What are the biggest benefits for students and teachers? The special part of PHBL is that students are facing challenges nowadays. We're living in a society which are full of technology, and the future trend of our society is going to be digital media, artificial intelligence. By only studying single project will not fulfill the needs for future generations. That's why phenomenal-based learning has been proposed. They want students to have a comprehensive understanding of the knowledge structure. They want them to understand the world in a more formational way instead of just learning on a 2D platform. They want students to feel the world, to experience the world, and to solve problems for the world and benefit humankind. And that way, I believe that beneficial it benefits the students and it benefits the society from the future references. And for teachers, we're actually giving a chance for our next generation to innovate, to discover something new by inventing a new educational way that has been pulling out a significant differences from decades ago. So I would say this is probably a new era for humankind. Right, so let's move on to the fourth question. We understand that, so this comment is quite interesting. So no teaching method is perfect. And of course, there are obviously some challenges when implementing PHBL. Yes. By using the teaching method of PHBL, teachers are having a massive workload because we have to collaborate with our colleagues from different subjects. We have to pull off an educational proposal that can beneficial all students, which means that we are facing a big challenges by writing up lessons and preparing for our lectures. Second of all, there's actually not a standard evaluation system for students to prepare such educational method. In other words, we cannot use exam to testify whether PHBL is workable or not. We cannot use a standard exam score like 90 out of 100 or 80 out of 100 to examine whether students are learning the knowledge or not. So we're looking at a more comprehensive and a more challenging educational method as well. All right, so we've moved to the final question. So this is actually talking about whether PHBL can work everywhere. Is it only effective in Finland, or can other countries adapt the approach as well? I would say the success in Finland, it's quite unique. So Finland has a low population of students, and most of the citizens in Finland has a high educational background. According to a field study, that 78% of people in Finland has at least a associate degree in a college level. But in that ways, that Finland actually don't have exams till students are entering universities. So students could be in the same classroom with the same pair of students for more than 10 years since they started elementary school. But I would say it might be challenging from other countries to do so. But excitingly, I've actually learned that the United States, Australia, and Singapore are like gradually starting to learn about using the method of phenomenal-based learning in a college or university level, but especially in subjects of STEM. So I've learned that there's one example I've seen that, which is in the University of UCLA. Students are actually collaborating from different departments, from engineering and from chemistry. So in that ways, students are actually trying to map out the lead platform of City of Los Angeles, and they're trying to discover a anti-earthquake device in Los Angeles using the engineering knowledge, chemistry, and also geology knowledge. Because we know that Los Angeles has been known for a lot of earthquakes throughout the year. And so students are trying to make a better service to their own community. But still, I would say the population and general educational level in a country would matter whether the phenomenal based learning can actually be workable or not. All right, so today we've actually discussed about the core concepts of PHBL, how it works in practice, its advantages and challenges it faces. While it is not perfect, it is undoubtedly reshaping the way that education has delivered worldwide. Let me know, what do you think, and do you think is PHBL the future of education? And don't forget to share your thoughts in the comments below. Thank you so much, everybody, by coming, and I'll see you next time.